All right, we're actually going to do one more problem here. I'm going to put this on the back. And I'm going to give you a situation, what we call the ambiguous case. This is where you might have two solutions. Okay, so let's say we've got a triangle here. Here's A, here's B, here's C. We know that angle A is 35 degrees. We know that the length of A is 17. We know that the length of B is 20. And we want to find beta. Okay, now, we know because 20 is bigger than 17, its opposite angle has to be bigger. So, if we do the law of sines, the sine of 35 degrees over 17 is equal to the sine of beta divided by 20. And we solve that. So what I would do here is 17 times the sine of beta equals 20 times the sine of 35 degrees, but then we would divide by 17. Now this will give us a decimal. So 20 times the sine of 35 divided by 17 equals, now that's equal to the sine of beta, so I take the inverse sine of that answer, and we get 42.4 degrees. Okay. Beta equals 42.4 degrees. Now here's the problem. Remember I showed you in the last set of notes, or two sets of notes ago, it's possible that the sine, when you do the inverse sine, it will only give you an acute value no matter what. Could beta actually be an obtuse angle? Now, if I subtract this from 180 and I subtract 42.4, I would get 137.6 degrees. Now, if I draw that, so again, we had 35 degrees, we had 17, we had 20. If I make this 137.6 degrees, this does not add up. This is less than 180. So if I take 35 plus 137.6, I can subtract that from 180, and that would give us a third angle of 7.4 degrees. Now this is possible, this triangle, even though that's a very small angle, this works here. And if I were to find my other missing side here, if I was to find C, I would take the sine of 7.4 degrees divided by C. I'll use sine of 35 degrees divided by 17 again. And so with my cross multiplying, I would do 17 times the sine of 7.4, and then I would divide that by the sine of 35. Okay, I didn't type it as a fraction, but that's fine. And I would get 3.8. So I would get C is equal to 3.8. Now this is possible. That actually works as a triangle. Remember, if you add the two shorter sides, it has to be greater than the third side for the triangle to exist. That exists. Now what would happen if I had not done this? What if I had used 42.4 degrees? Okay, now I want to find what C is. So first of all, I could add these up and subtract from 180 to find the missing angle. So 35 plus 42.4 equals 180 minus that. Now that would be 102.6. So now that would be the biggest angle. I could then do the sine of 102.6 degrees divided by the length of its opposite side, C, equals the sine of 35 degrees divided by 17. Now again, we're going to cross multiply, so we would do 17 times this. I'll put it in a fraction this time. 17 times the sine of 102.6 We would then do c times the sine of 35 degrees, but then we would turn around and divide by the sine of 35. And that answer is 28.9. So the length of c is 28.9. Does that work? Well, if I go back to my picture here, my sides are 20, 17, and 28.9. If I add the two shorter sides, is it greater than 28.9? Yes, it is. Okay, so here's what happens. We actually have two possible solutions to this problem. The reason it's called ambiguous means unclear. This is a situation. Now, it doesn't happen a lot, but it is a case where we have an unclear situation. You have to be aware that this is a possibility. So when you're solving these problems, now if it's a word problem, some kind of application, then it might make sense to only use the acute measure that we get. Or it might make sense that this would have to be an obtuse value. So you may not have to do two cases. If you're solving for the side, you don't have to worry about it. And if you know that you're solving for a smaller angle, you don't have to worry about it. So in most of these situations, it doesn't matter. But going back to the front here, if it's a side-side angle situation, and if this angle would be, so we're missing an angle here. If this side is longer than this one, so if this is a bigger angle, we have to be aware that possibly this could be an obtuse measure. And that is the end of the